the next technique, elimination. Elimination is what we use if we can't do substitution. And so what you want to do is try to eliminate a variable by combining your equations by either addition or subtraction. It's usually easier to use addition, so that's what I will typically use. So let's take a look at the example that we have here. We want to solve the system of equations, and we're going to use elimination. Notice that we can't use substitution because none of our variables have a coefficient of 1. They all have a coefficient of either 3, 4, or 6. So we can't use substitution. So what we'd like to do is we'd like to be able to add our two equations together, and by doing that, eliminate one of the variables. So what you want to keep an eye out for are any coefficients that are multiples of each other. So for example, 3 and 6. 6 is a multiple of 3, and so if we could make the first equation, instead of being 3x, if we could multiply it by some number so that it was a 6x, well then we might be able to eliminate the two 6x's in our system. So the idea is, if I want to be able to eliminate a positive 6x, then our goal is to make the other term a negative 6x. So this means that we're going to want to multiply our first equation by negative 2, so the 3x becomes negative 6x. So we multiply the entire first equation by negative 2. So this leaves us with negative 6x minus 8y equals positive 44. And the second equation remains unchanged. So we have 6x plus 3y equals negative 9. So now we have two coefficients from the different equations that are equal but opposite. And so what we can do in order to eliminate the x variable is add these two equations together. So we add like terms. So negative 6x plus 6x, those two combine to 0. Negative 8y plus 3y is going to give us negative 5y, and 44 minus 9 will give us 35. So now we have a much simpler equation that we can easily solve for y. So if we take negative 5y equals 35, divide both sides by negative 5, and so y must equal negative 7. Now just like we did before, we can take our solution and plug it into a previous equation to solve for the second variable. So let's take our solution for y, and I'm going to evaluate it in the second equation. It doesn't matter if you plug it into the first or the second, you should get the same answer either way. So I'm going to take my second equation, 6x plus 3y, but now instead of the variable y, I have the value negative 7. And this should equal negative 9. So we have 6x minus 21 equals negative 9. So if we add 21 to both sides, we get 6x equals 12. So dividing by 6, x must equal 2. And so our final solution then is the point. Our solution will be the coordinate pair x value 2, y value negative 7. We can of course check our solution. So let's go ahead and do that. I'm going to evaluate the first equation for x equals 2 and y equals negative 7. So 3 times 2 plus 4 times negative 7. Does this equal negative 22? Well, let's see. 3 times 2 is 6. 4 times negative 7 would be negative 28. Negative 28 plus 6 is equal to negative 22. So that works. So we know it works for the first equation. Let's try it for the second one. Let's see, we have 6 times 2 plus 3 times negative 7 equals negative 9. Is this true? Well, negative 6 times 2 would be negative 12. 3 times negative 7 would be negative 21. Negative 12 minus 21 is not negative 9. Why not? Let's see. 6x, Oh, I have an extra negative right here. This negative should not be here. This is positive 6x, not negative 6x. So this negative should be gone, giving us a positive 12 minus 21, which does indeed equal negative 9. Okay, good. Whew, everything worked out. So we found our solution to be 2, negative 7, and we furthermore are able to check our solution, and indeed it is a solution for both parts of the system of equations.